Hey everyone, today we're going to solve an equation that has all unknowns and we're going to solve it for C. That is, we're going to isolate this equation for C, okay? So to start that off, we know C is embedded inside of a square root inside the denominator. So what we could do is, to first starters, multiply both sides by that entire square root in the denominator on the right side. So to do that, we'll multiply by the square root of a squared minus b squared c squared. And again, over here, that means that'll cancel out on the right-hand side. And that means on the left, we'll have 2m square root of a squared minus b squared c squared is now equal to just m, right? And now we again know that c squared is embedded inside a square root. So to get rid of the square root, we could square both sides right now. Actually, let's divide by 2m first to make our life a tiny bit easier before we square both sides. There's more than one way to go about this. This is just the way that I think would be best. So the 2m's will therefore cancel out. And so now we'll have that square root isolated on the left-hand side. And it'll be equal to n over 2m, like so. And now, to get rid of that square root, let's square both sides finally. So we square and we square. So on the left, the square root cancels out the square, and we get a squared minus b squared c squared is equal to, that square hits everything, every component inside the bracket, meaning we get n squared over 4m squared. Now again, we want to isolate the c squared. Right now it is negative, and that's not necessarily a problem. So let's isolate the term that has the c squared first. Let's get rid of that a squared. So minus a squared minus a squared. So now negative b squared c squared is going to be, we should probably go ahead and write this over a common denominator. And so a squared is the same as a squared times 4m squared over 4m squared. And so that means that this is equal to n squared minus 4a squared m squared all over m squared, like so. And now we can go ahead and divide by that negative b squared. And so we divide by negative b squared, again, in isolating the c, right? And so we divide by negative b squared. That means it's going to get tacked on to this denominator that is already there, right? We're dividing it so it joins in on the denominator. And so now we're almost done. We have c squared is equal to, now we have a negative in the denominator, right? To get rid of that, we can multiply the top and the bottom by -1, right? Which really means changing the sign on each term. And so, in other words, we'll have, I'm going to change the order around. We'll have 4a squared m squared minus n squared all over b squared m squared. And finally, to get rid of the square on the c, because we're solving for c, we'll take the square root of the entirety of both sides. And so, in the end, we end up with c being the square root of the numerator. The numerator is a binomial, right? We have two terms. We can't just take the square root of each individual term on its own, right? As tempting as that might be, we absolutely can't do that, right? So we have to leave the numerator as the square root of that binomial. And so that means the square root of 4, what is it? A squared m squared minus n squared all over, but in the in the denominator, the square root of b squared m squared is just bm. And so that one we can simplify, and here is our end result. I really like this one. It's just a nice radical equation that serves as a good exercise in algebra. I hope you guys find that helpful. Thanks for watching, and let me know if you have any other questions like these on radical equations or any really algebra heavy exercise that you'd like a video on. Thanks again.